Hello guys, welcome to today's lesson. As you can probably tell, we are having this new series. Well, I will still be uploading in the other series. I will be focusing on this for today's lesson and perhaps some future lessons. So I was trying to introduce some competitive maths ideas and knowledges and try to see how I can help people. And I realized the fundamentals of them are all the same. You just gotta know how to cope with these problems. And yeah, why not get started? So in today's lesson, we're going to talk about divisibility and the Euclidean algorithm, which I'm going to write here. Divisibility and the Euclidean theorem. You should have heard of them before, but I'm still going to explain them. So what is divisibility? Almost every statement in number theory is equivalent to A divides B for some expressions A, B. So this essentially means that B equals to Ka, for K is a whole number. And positive, yeah. And we put asterisk there. We can combine these statements in several ways. So here are all the basic things you know, but then it's just common sense. A divides B, so A divides by a multiple of B. So that's really straightforward. And then if A divides B and A divides C, B divides C, then A divides C. Because C is a multiple of B, we're just expressing that in a different term. And then if A divides by B and A divides C, then A divides by bx plus cy, because they're all multiples of A, so we can multiply by any whole number, x or y, to get a new multiple. And A divides B, then AM divides BM for the same concept. We are having a integer m, but then m cannot be 0 in this case. Not really straightforward. And then this is the basis of the Euclidean theorem algorithm, which is a more efficient way to compute the greatest common divisor of two numbers than prime factorization. So essentially what you're doing is, if you have a k, and then you want to find the greatest common divisor between k and n, then what you're essentially doing is see how many times n multiplies by k, and then k divides by the maximum xn, and then that you divide minus by the remainder times a new random number that gives you the maximum output. And let's get an example going on. So 21n plus 4 over 14n plus 3. And explain why this is irreducible for any integer n. And this is really easy. So essentially we're just finding the greatest common divisor. And we want them to be 1 because it's not reducible, because they don't have any common factors anymore. So between 21n plus 4 and 14n plus 3. So in this case, it's really easy because we can just use the Euclidean theorem. And how many times does 14 multiply into 21? That's just one time, so 7n plus 1 and 14n plus 3. And we're just finding the greatest common divisor between these two, and we can just multiply that back in, which gives us 7n plus 1 and 1. And to be fair, you can just tell 7n plus 1 and 1, that just is 1. So because the greatest common divisor is 1, which is correct for all integers, then this fraction is irreducible because it doesn't have any other common factors. And okay, just a clarification here. So the Euclidean algorithm is well known and can be cited without proof when you're writing in a competition such as the AIME or the IMO, or your perhaps BMO for your UKMTs. And but we can still ask how we can prove it rigorously, and the answer lies in divisibility in terms of prime factorization. So for the remainder of these notes, so VP and then bracket n, we're finding the highest power of p that divides n. Okay, now I'm going to give you an example. V2, 100. So if you factorize 100, we can see is 2 to the power of 2 times 5 to the power of 2. And then so the highest power of 2 here is 2. And that would give us 2. And V2 for 30, because 30 is equals to 2 times 3 times 5, will just be 1. This will be useful later on. And now we have some new formulas for you to know. So if A divides B, then the greatest power of P that goes into A is smaller or equals to the greatest power of P that goes into B, because it is a multiple of A, and there only exists a chance for it to be bigger than or equals to the greatest power available for P to be divided into both integers to stand only when A is smaller than B, which is accurate because B is a multiple of A. And the greatest common divisor of A and B is equals to the multiplication sum of until P for all P to the power of min between VPA and VPB. This is a really frustrating, and to be honest, I would swear at the guy who made this because he's just overcomplicating. So all you're doing is you're finding all the P to the power of the greatest power available, or the smallest power available, because you're finding the greatest common divisor, and then you just multiply them together. That's how you find the greatest common divisor, but like in a more mathematical expression. And then the lowest common multiple is just max, which is understandable because it's the biggest. And then let's do some questions. So let's look. So find an integer pair of x and y satisfying 19x plus 23y equals to 1. And this is really straightforward because we're just finding a greatest common divisor of 1. So 19x and 23y, we can just use the Euclidean algorithm. 23 equals to 19 times 1 plus 4, and 19 equals to 4 times 4 plus 3, and 4 equals to 3 times 1 plus 1. And you see, there's a plus 1. So now we inverse it. So 1 equals to 4 take away 3, and then 1 equals to 4 take away, what's 3? 19 take away 6, take away 4 times 4. And then we can change the, we can move it outside because it's both 4, so 1 equals to 4 plus, so 5 times 4, take away 19 times 1. And then we can simplify the 4 because we know what the 4 is. 4 is 23 take away 19. Multiply by 23 take away 19. Take away 19. And then 5, so 1 equals to 5 times 23, take away 5 times 19, take away 19. So the thing is just 5 times 23, take away 6 times 19. Easy. So a pair of xy for y is for 23, x for 19, so it would be -6 and 5 as the answer. Yay. And that is a really common competition question, I would suppose, because it is really common. And let's look at some other. Okay, now so we introduced Bizut's lemma, or Vizu. I don't know, it sounds pretty French, but then I actually have no idea how to pronounce this. You can type in the chat. This lemma. If the greatest common divisor of x and y equals, please don't mind my handwriting, it's really bad because I don't really have a pen, is equals to d, then there exists a pair of mn, that mx plus ny equals to d. Yeah, this is just Euclidean's theorem, but then, you know, expressed in a different way. And we can skip all the rest because it's really easy. And okay, now here's a question. Let a, b, n be the integers where a, b is bigger than 0. So a, b, n are integers. What are integers? Z plus. Where a and b are both bigger than 0, determine the number of distinct solutions in terms of d, mod n, sorry, in terms of n to the congruence ax gives a remainder of b when modded n. Okay, so since b is the solution from modding ax to n, then we know that let's create a n divided by ax take away b, because if we move b to the other side, we know that ax take away b gives 0 mod n, so it's a multiple of n. And let d equals to the greatest common multiple between a and n. Then d divides by n. So if we create a new d, integer d, that divides n and a, then we know that d divides by ax take away b, since ax take away b is a multiple of n. And since d also divides a, b must divide d. So this we know is a multiple of a. Then we know b also have to be a multiple of d. So suppose d divides by b, then according to the Bezout's lemma, there exists PQ, such that AP plus NQ, because we know these two, they both divide by that because it's the greatest common divisor. I think that we did not assign. Okay, so greatest common divisor between A and N equals to D. Yeah, let's assign that first. And then suppose that B divides by D also, because we just proved that. Then by Bezout's lemma, there exists new numbers. Let's call them PQ. So that AP plus NQ gives us D. So AP multiplied by B over D plus, sorry, I should close that bracket, NQ multiplied by B over D gives us B, because we're just multiplying that on all sides. So now we know that gives us B, so X equals to PB over D is a solution. You can see PB over D, because that's what we're multiplying PB over D by is. So therefore B is the how do I say this, the greatest common divisor between AX and N. And we're just finding the coefficient for A.